In this lesson, we are going to learn how to find the derivative of functions using the L'Hopital's rule. So let's look at what the L'Hopital's rule says. So it says that if you are to find the limit of this function f of x divided by g of x as x approaches c, this is the same as taking the limit of the first derivative of the function f of x divided by the first derivative of the function g of x, okay, as x approaches c. So what you have here is the same as what you have here. That's what L'Hopital's rule says. So if you have a quotient of functions and then you have to find their derivative, you have to find their limits, all you have to do is to differentiate the function you have on top and then differentiate the function you have down there, then you do your direct substitution. If after doing the first derivative you still didn't get your answer, you will have to differentiate again. Then you try direct substitution and see if you get your answer. If you don't get your answer, then you differentiate again. So let's take an example to help us understand this. So we have the first example here. The limit as x approaches 0 for the function sine of x divided by x multiplying 1 plus cosine of what? X. Okay, so we have this function here and you have to find the limit as x approaches 0. If you try direct substitution, you're going to get 0 over 0, which is indeterminate. So let's find a way to get the limit for this function. To do this, you are going to apply the L'Hopital's rule. Okay, so we are going to let f of x be equal to sine of x and then g of x to be equal to x multiplying 1 plus cosine of x. Okay, so we have this here. So what we need here now is f prime of x and then g prime of what? X. Okay, and then what you have to know is that f prime of x is the same as the f of x dx. Okay, and then g prime of x is also the same as the g of x dx. So if you don't see f prime of x and g prime of x and you see this, they are all the same. So let's find the derivative of these two functions here. F prime of x, okay, will be equal to that the derivative of sine x, that will give us cosine of what? X. Okay, so now let's find the derivative of what? G of x, which will be g prime of what? X. So I'm going to treat this as I'm going to apply product rule here to find this derivative. Okay, so first of all, I'll find the derivative of x, then I'll keep this side as a constant. The derivative of x is 1, so I'm going to have 1 multiplying 1 plus cosine of what? X, right? And then now plus, I'll now keep x as a constant, then I'll find the derivative of what you have inside. The derivative of 1 is 0, and then the derivative of cosine of x is minus sine of what? X, right? Okay, so now let's simplify this. So I'm going to have 1 plus cosine of x minus x sine of what? X. Okay, so this is what you have now. So now let's come and do the substitution and see what you get. So I'm going to have the limit as x approaches 0, and then after differentiating, you got the f prime of x to be cosine of x. Okay, then divided by the derivative of the function you have down there, which was 1 plus cosine of x minus x sine of what? X. Okay, so let's try the direct substitution. So you're going to have cos 0 divided by 1 plus cosine of 0 minus 0 multiplying sine of what? 0. Okay, so when you simplify this, cos 0 will give us 1, and then we'll have 1 plus 1, okay, because of this cos 0 here. And then over here, because of this 0 multiplying sine 0, we're going to get 0. So we're going to have plus, sorry, we're going to have minus 0 here. So when you simplify this, that gives us 1 over 2. So the limit of the function will be 1 over 2. So applying L'Hopital's rule will help you to find the limit of this kind of functions. Let's try our hands on another example. Okay, so we will take another example. So let's find the limit as x approaches pi on 2 for the function 1 minus sine of x divided by cosine of x. Okay, so let's find the limit of this function. But first of all, let's try direct substitution and see what we get. We're going to have 1 minus sine of pi on 2 divided by cosine of pi on 2. So let's simplify this and see what we get. We have 1 minus sine of pi on 2. Sine of pi on 2 gives us a value of what? 1. Okay, if you want to do this computation, make sure you set your calculator to radians. So this divided by cosine of pi on 2, that's 0. So you're going to have 0 over 0, which is indeterminate. So you have to find a different way to evaluate the limit. So let's apply the L'Hopital's rule here. You're going to let f of x, okay, f of x to be equal to 1 minus sine of x. Then g of x to be equal to cosine of what? X. Now let's find the derivative of these two functions, which will be f prime of x. So for f prime of x, we know that the derivative of 1 is 0. So we're going to have 0 minus the derivative of what? Sine of x, which is cosine of x. Right, so this will give us minus cosine of what? X. So let's find the derivative of what? G of x, which will be g prime of what? X. That would be equal to minus sine of x. Right. So now let's do the substitution. So I'm going to have the limit as x approaches pi on 2 of the function f prime of x, which is minus cosine of x now, and then divided by minus sine of what? X, right? So these two negatives can cancel out, and then you can do direct substitution and then see what will happen. So I'm going to have cosine of pi on 2 divided by sine of pi on 2. So let's do this and see. Cosine of pi on 2 gives us 0, and then sine of pi on 2 will give us 1. So I'm going to have 1 over 0, and then this will be 0. So therefore, the limit of the function will be 0. Okay, so let's try our hands on another example. Okay, so we have to find the limit. Okay, let me write this here. We have to find the limit as x approaches 1 for the function x to the power 4 minus the square root of x, okay, divided by square root of x minus 1. So let's look at how we're going to find this limit. When you try direct substitution, you're going to have 0 over 0, which is indeterminate. So you will have to find a way to find this limit. So I'm going to apply L'Hopital's rule. So let's take f of x to be equal to x to the power 4 minus the square root of what? X, and then g of x to be equal to square root of x minus 1. So let's find the derivative of these two functions. So f prime of x will be equal to 4x to the power 3, okay, minus the derivative of what? Square root of what? X. So let's rewrite square root of x as x to the power half, right? So the derivative will be 1 over 2 times x to the power half minus 1. That will be equal to 1 over 2 x to the power minus half. Okay, I can write this as 1 over 2 root x. Okay, this is what we have. So the derivative of square root of x will be 1 over 2 root x. Let's take note of that. So let's find the derivative of what? G of x. That will be g prime of what? X. Okay, so we know that the derivative of square root of x will be 1 over 2 root x. And then the derivative of 1, which is a constant, will be what? 0, so minus 0. So now let's do the substitution. So we are going to have the the limit as x approaches 1 of f prime of x divided by g prime of x, right? And you know f prime of x to be 4x cubed minus 1 over 2 root x, right? Divided by g prime of x. Okay, so in this case, I'll do it divided by 1 over 2 root x. Okay, so this is what we have now. So what we will just do is that let's do direct substitution. So we're going to have 4 into bracket 1 cube minus 1 over 2 square root of 1 divided by 1 over 2 square root of what? 1, right? So 4 times 1 to the power 3 will give us 4, and then minus 1 over 2 root 1, right? So 1 over 2 root 1, that gives us 1 over 2, so minus 1 over 2. Okay, divided by 1 over 2. So let's look at what we are going to get. 4 minus half. 4 minus 1 over 2 will give us 7 over 2. We're going to have 7 over 2. Okay, I took this side first. We're going to have 7 over 2 divided by what? 1 over 2. So when I reciprocate 1 over 2, that'll give me 7 over 2 times what? 2. Right? And then these two will cancel out these two. So I'm going to have 7. So that'll be the limit of the function. Okay guys, let's try our hands on one more example. So let's find the limit as x approaches 1 for the function 5x to the power 4 minus 4x squared minus 1, okay, divided by 10 minus x minus 9x to the power 3. So let's find the limit of this function here as x approaches 1. Okay, so when we try direct substitution here, we are going to get 0 on 0, which is indeterminate. Okay, so for that reason, let's find a way to find the limit. So we're going to apply L'Hopital's rule here. So we will let, okay, it's not you will let f of x to be equal to 5x to the power 4 minus 4x squared minus 1, and then we will let g of x to be equal to 10 minus x minus 9x cubed. So you will have to find the derivative of these two functions here. Okay, so that will be f prime of what? X. Okay, so for the first function f of x, you're going to have 5 multiplying 4x cubed, right, minus 4 multiplying 2x, and then the derivative of minus 1 is 0. So when you simplify this, you're going to have 20x cubed minus 8x minus 8x. Okay, this is what we have. So now let's do same for the second function g of x. So g prime of x, you're going to have the derivative of 10, which is a constant, is 0, and then the derivative of minus x will be minus 1, and then we'll have minus 9 multiplying 3x squared. So let's simplify this. I'm going to have minus 1 minus 27x squared. So we've gotten our derivatives. So let's try direct substitution and see. One thing about L'Hopital's rule is that after differentiating the function once and then you try direct substitution and then you don't get the limit, you can differentiate again. Then when differentiate again and then you don't get the limit, you can differentiate again till you get the limit. So you just have to keep differentiating if you're not getting the limit. So let's try the direct substitution. So we're going to have the limit as x approaches 1. We have f prime of x to be 20x cubed minus 8x, okay, divided by minus 1 minus 27x squared. Now let's try the direct substitution again. So we're going to have 20 into bracket 1 to the power 3 minus 8 to bracket 1, okay, divided by minus 1 minus 27 to bracket 1 squared. Okay, when you simplify this, you're going to have 20 minus 8 divided by minus 1 minus 27. Okay, so let's simplify this here. 20 minus 8 will give us 12, and then minus 1 minus 27, that gives us minus 28. 8, right? So we have 12 divided by minus 28, and that will give us minus 3 on 7. So that will be the limit of the function as x approaches 1. So like I said, if you differentiate for the first time and you're not able to get the limit as in what you did here, okay, so let's assume that after differentiating and we got this, we place the 1 inside and then we got indeterminate form, then that means you will have to differentiate this function here again. Then after that, we substitute the 1 in. If you get it, then that's it. If you don't get it, then you have to differentiate what you got again. That's how to apply the L'Hopital's rule. So let's try our hands on this question. Let's find the limit as x approaches 0. Okay, for the function 1 minus cosine of 2x divided by x squared. Okay, you're supposed to get your answer as 2. Okay, so that's all for this video. Thank you very much for watching. Please make sure you like and subscribe.